Hello everyone, welcome to this new video. So in our previous sessions we had discussed a lot of concepts in this second chapter. Just recall it. One about the line integrals, work done, and about the Green's theorem. And now we have one final topic in this module of vector integration chapter, that is related to surface integrals. Okay, we are going to solve some complicated surface integral problems using Stokes theorem. Okay, you can see a Stokes theorem, very important theorem. Okay, one question is fixed from this topic, from related to Stokes theorem. All the problems which I am going to solve are related to Stokes theorem, okay, in this surface integrals. So let us see something about surface integrals as well as Stokes theorem, and let us see how can we solve these kind of problems. Okay, first surface integrals, let us see how. So previous videos related to line integrals and all, the detailed explanation along with all the problems, it is available in this playlist only just before these videos. Those who have not seen it and those who are new to this video, please go and watch it. It is available in the playlist. Okay, yeah, let us continue now. An integral evaluated over a surface is called a surface integral. Okay, so this is the basic definition of a surface integral. An integral evaluated over a surface. Okay, for example, there would be one closed surface or an open surface. An integral evaluated over that surface. For example, if we have a circle here, an integral over this surface which covers all the boundaries is called as a surface integral. Okay, consider a point P on a surface S, and let a vector or a constant vector be a vector function if the values of x, y, z are defined as continuous over the surface S. Okay, then the integral over the surface S is given by surface integral, that is all. Surface integral is always a double integral. Okay, so double integral with the apostrophe S. So surface integral over a closed surface or an open surface is equal to is given as a vector dot n cap into ds. Okay, so this is the general way how the surface integral is represented. That is, surface integral over a surface, a vector, which is any constant vector they would be giving you in the question, dot, that is dot product with the unit vector n cap, which is the unit outward normal to the surface at the point P, and ds is the small elemental area. Okay, so this ds is called as the smallest elemental area. In generally, if we have around xy plane the surface, then generally it is the ds is represented as dx into dy. Okay, small elemental area, and it is given as dx into dy, and this n cap is the unit outward normal to the surface. It is the outward normal unit vector. Okay, yeah, so this was about the complete surface integrals, so please note it down. Now let us see about Stokes theorem. Okay, Stokes theorem: if S is the surface bounded by the simple closed curve C, and if F is any continuously differentiable vector. Continuously differentiable vector means it could be differentiated at any instance of time, okay, at that particular area. Okay, so if F is any continuously differentiable vector, then the function of Stokes theorem is represented as an integral over a closed surface f dot dr is equal to the surface integral curl of f vector, that is del cross f vector, dot product with the n cap, that is the unit vector, unit outward elemental vector, into the ds, that is the differential elemental area. Okay, so in this way the Stokes theorem equation is going place. That is, in order to calculate the integral of f dot dr, so f dot dr is equal to surface integral of del cross f dot n cap into ds, where ds is the is equal to dx into dy, and n cap is the positive unit vector outwardly drawn normal to the surface S. Okay, so this is the general formula of the Stokes theorem. F dot dr is equal to this formula. Okay, this you should be remembering very carefully, because related to this we are going to solve few problems, okay, in this video. So this was the complete intro part related to surface integrals and Stokes theorem. Now we are having a few problems in this video that we are going to solve it in a quick manner. Okay, so let us see the questions now. So this is the first problem related to surface integral Stokes theorem problems. Problem number 1: evaluate the integral over f dot dr, where f is a force vector, dr is the differential vector, by Stokes theorem for the vector shown below. That is, the f vector is given here. That is, f vector is equal to x square plus y square into I cap minus 2xy j cap, taken around the rectangular boundary by surrounded by a boundary of rectangle in the particular area where x is equal to plus or minus a, y is equal to 0 and y is equal to b. So these are the conditions given. Seeing the conditions, let us draw the plot now first. Okay, the Cartesian plane xy first, draw it. And what and all they have given? One, they have given x is equal to plus a. Okay, plus a means any constant which which starts in the positive quadrant. Okay, which lies somewhere here. Okay, so this is x equal to a, and similarly the opposite side we would be having x equal to minus a, and one more line they have given y equal to 0 and y equal to b. Okay, so y equal to b might be here somewhere, and y equal to 0 is this line. Okay, so this represents y equal to 0. Now these all points meet and intersect each other to form a rectangle here. See here. So this is a rectangular surface formed by these points which I have marked here. Okay, so hope it is clear. So here, seeing these things, we could write the limits now. For x it is from minus a to plus a, and for y, if you see here, it is from 0 to b. Okay, we don't have any surface here down, so y is equal to 0 to b, and x limits are from minus a to a. Okay, so these are the limits for x and y. Now let us solve using Stokes theorem. First, write the Stokes theorem formula. The formula says that line integral of f dot dr is equal to the surface integral of curl of f vector dot n cap, that is the unit vector, into the differential area. Okay, so this is the Stokes theorem formula. So according to this, first we should be finding the curl of f vector, that is del cross f vector. Okay, let us find that first. For that we should be using the determinant. Hope you might be knowing it. First column are all the unit vectors I cap, j cap, k cap. Second column all the partial derivatives. Third column all the coefficients, that is first x square plus y square. Then we have minus 2xy. So k cap term is not there, so we could be simply writing it as 0. Okay. Now solve the determinant. Del cross f I cap into these two, dou by dou y into 0, that is 0, minus dou by dou z into this term. So with this we should be partially differentiating with respect to z, but we don't have any z term, so we could be writing it as 0, minus j cap into these two terms, dou by dou x into 0 is 0, dou by dou z into this term, again we don't have any z term, so again it is 0, plus k cap into dou by dou x into minus 2xy. So minus 2y is constant, differentiation of x is 1, so minus 2y remains, minus of dou by dou y into x square plus y square. So x square with respect to y, so this is cancelled, so differentiation of y square is 2y. Okay, so we would be getting our answer del cross f is equal to, so this is 0, I cap j cap term goes, so minus 2y is minus 4y k cap, right? So this is the curl of f vector we have found. Now next we should be writing the n cap, that is the differential unit vector, right? So it is represented, it is given as, n cap is generally given as I cap into dy dz. Since they have given I cap, j cap, k cap, all three of them, so this is a three-dimensional surface, so we should be writing all three terms, I cap into, starting from dy dz plus j cap into dx dz plus k cap into dx dy. Okay, since it is a surface integral, so we need to have two at a time. Okay, so in this way normally the unit vector is represented. Now next thing is del cross f vector dot product with this unit vector, right? So this has to be done here according to the formula. Okay, do that. Del cross f dot n vector is equal to What is del cross f? We have got minus 4y k cap dot product with this term, that is I cap into dy dz plus j cap into dx dz plus k cap into dx dy, right? So if you see here 4y k cap and I cap, so this would be 0. So we would be left with only last term, that is 4y k cap minus 4y k cap into dx dy. Okay, if you solve that, k cap into k cap is 1. So we would be left with minus 4y dx dy. Okay, so this is the required del cross f dot n vector. Okay, where this dx dy is equal to ds. So this much you have done. Now finally this whatever we have got here, that you should be integrating. Okay, so let us do that integration part now. That is f dot dr is equal to surface integral double integral, okay, del cross f dot n cap into ds. So here first I'll write the limits of x from minus a to a, limits of y from 0 to b, and whatever answer we have got here, that is minus 4y dy dx. Okay, ds have replaced it by dy dx. So now solve this, and whatever answer is we get, that is our final answer. Okay, minus a to a, solve the inner integral. So minus 4 you can take it common outside. So y dy remains, the integral of y is y square by 2, limits from 0 to b dx, minus 4 minus a to a. So apply the limits, that is b square by 2 minus 0 into dx, that is minus 4. So this is b square by 2 into dx. So this term is full constant, we can take it outside, a whole term, minus 4 b square by 2 minus a to a dx. So minus 4 b square by 2 into integration of dx is x, and the limits are from minus a to plus a. 2 1s are, 2 2s are. So we are left with minus 2b square, and here upper limit is a minus of minus a. So we would be getting minus 2b square, a minus of minus a is a plus a, minus 2b square into 2a. So we would be getting our final answer as 2 2s are 4, minus 4ab square. Okay, so this is our required answer, which we have solved using Stokes theorem. So hope it is clear how to solve. So please note this problem down, very important. Let us get to the next question now. So this is the next question. Evaluate line integral of f dot dr by Stokes theorem for vector field f given by 2x minus y I cap minus yz square j cap minus y square z k cap over the upper half of the sphere bounded by its projection on the xy plane. Okay, here they are mentioned over the upper half of the sphere. Okay, they have mentioned only the upper half, so you could be writing one simple hemisphere. Okay, hemisphere, you know, right? Sphere which is divided into two parts in a 3-dimensional surface is called as a hemisphere. So that you should be drawing as a plot here. So let us draw that first and see. And again, one more thing they have mentioned, xy plane. So whenever they say xy plane, I have told you, right, the z plane is equal to 0. So dz also would be equal to 0. Okay, whenever xy plane is given, you should be knowing it. So now let us draw the projection. Y, x. They have told us to draw an upper half of the sphere. Okay, let us draw that roughly. So this is the upper half of the sphere, and the radius of this is equal to 1. Because the equation they have not mentioned it, that is x square plus y square plus z square is equal to 1. Okay, so this is the equation that I have not written. So in this here, the radius, in place of radius we have 1 square, so radius would be equal to 1. So this is the point 1, 0, and this is the origin. Okay, so this is the plot here. Now let us try to find the f dot dr using Stokes theorem. First write the given f vector 2x minus y according to the given question I cap minus y z square j cap minus y square z k cap. Right? Firstly, find the curl of f vector del cross f. First column, all the unit vectors, all the partial derivatives, second column, and the coefficients 2x minus y minus yz square minus y square z. Okay. Now solve using or do the determinants of calculation. I cap into dou by dou y into this term. So partially differentiate this term with respect to y. Z is constant, so differentiation of minus y square is minus 2y minus of, here we have dou by dou z with this term, so minus y is constant, and z square differentiation is 2z, so minus 2yz minus j cap into dou by dou x into this term, we don't have any x term here, so 0, minus dou by dou z into this term, again we don't have any z term here, so again 0, plus k cap into dou by dou x into minus of yz square, no x term again, so 0, dou by dou y into this term, so differentiation 2x is 0, so differentiation of minus y is minus 1. Okay, so solve it. I cap into minus 2y plus 2yz, and j cap term goes, we are left with k cap into 0 plus 1. So our answer is so here it is 2yz. Okay, here z term I have now forgot to write, right? So this is 2yz, sorry. Okay, here z term I forgot to write it when I did here. So 2yz, so minus 2zy plus 2yz, so this would be again 0. So you would be left with only del cross f is equal to 0 plus 1 is 1, so del cross f is equal to k cap. Right? Now the limits part I forgot to write. X limit is from 0 to 1 because the radius they have mentioned only from 0 to 1, and y limit, since it is a half sphere, so it is from 0 to pi. Okay, this half sphere is 180 degree, right? So these are the limits x and y. Now del cross f dot n cap is equal to k cap into I cap dy dz plus j cap dx dz plus k cap dx dy. Okay, so I will solve it. What we will be getting? So this into this is 0 plus 0 plus dy dx. So we will be getting del cross f dot n cap is equal to dy dx. Right? So this we should be integrating now. So our f dot dr is equal to double integral dy dx, where outward we should be writing the limits of x, that is from 0 to 1, and limits of y are from 0 to pi. Okay, solve it. 0 to 1 dy integration is y 0 to pi dx 0 to 1. So upper limit minus lower limit. Pi minus 0 is pi, so pi dx. So pi is constant, take it outside. And integration of dx is x only from 0 to 1. So pi into upper limit 1 minus 0. So our answer is f dot dr is equal to pi. Pi into 1 is pi. So this is our answer which we have solved using Stokes theorem. Okay. Hope it is clear. Just see the problem again, once again, and try to understand each and every step carefully. So yeah. So this was the problem, guys. Note it down. So we'll see you in the next video with some other set of problems related to Stokes theorem. Okay. Like, share, subscribe to our channel. Thank you.